Hello friends, this video on DNF block elements part 14 is brought to you by examfear.com. No more fear from exam. Now we'll understand the atomic size trend. Before that, let's understand the basis to understand the atomic size trend. The first thing we should note is that due to the presence of electron in the inner cell, the outer shell will not experience the full positive charge of the nucleus, but the experience will be lowered, and this is called the partial screening of positive charge by the nucleus of inner cell. For example, this is my nucleus, and we have different shells here, right? This electron will not experience the full positive charge from this nucleus. This charge will be screened by these shells. Okay, so it will have some ZFE. Okay, Z is the full nuclear charge. What it will experience is the Z effective E. Okay, and this is called shielding effect. And we'll talk about the shielding effect of S, P, and D orbital. And despite the shielding effect, despite the shielding effect of the outer electrons from the nucleus of the inner shell electrons, the attractive force experienced by the outer shell electrons increase with increase in negative charge. When there is a shielding effect, the more you increase the charge, the Z effect increase. We have seen that. And thus the energy of interaction between the nucleus and the electron decreases with increase in atomic number. This is something we have seen. The nucleus and the electron, right, the interaction between them decreases with increase in atomic number. So we talk about the atomic size. We have van der Waals radius, where this is again, in that case, we imagine the radius of an imaginary hard sphere, and where there is no bond formation. So we found get this van der Waals radius. It is pretty big in size as compared to other radius. Covalent radius, actually, if you see, they are in the bond, in the covalent bond. It's a measure of one size of an atom that forms a part of a covalent bond. And then similarly, we have an ionic radius. Ionic radius is again the radius where we have the ionic bond. So van der Waals radius is big. For example, in this case, if you see, these two atoms are not linked together, right? So the van der Waals radius is the blue one, and in this case, if you see, these two atoms are bonded together. So the radius is the red one. If you see that there's a difference in the red and the blue one. The blue one is the bigger one, the red one is the smaller one. Typically, if we get this van der Waals radius for the noble metals, they don't react and they don't form bonds. But typically, when we talk about the atomic size, we talk about the average atomic size of all these kind of radius, or average atomic radius is nothing but you take the average of all the atomic radius for a given metal that forms with different compounds and come up with the average atomic radius. Let's talk about an important concept called shielding effect. See, if there's a nucleus here and it has some neutrons, the electrons somewhere here will not experience the full nuclear charge. The charge will be shielded by this S orbital, again one more S orbital, and there's a P orbital. And then we have something called D orbital also, which I have not shown in this picture. Now understand why S orbital has maximum shielding effect. Assuming this is my nucleus and it has some positive charge, huge positive charge, and this positive charge actually is shielded by this S orbital. S orbital is spherical in shape. So since it is spherical in shape, it will actually shield the charge. Assume nucleus like precious gold. Let's suppose this nucleus is a precious gold, right? Now if you are shielding with a spherical cloud of electrons, do you think the protection is more? Yes. Instead of spherical electrons, if you are shielding with this kind of shape, this is P orbital. If you see, the green one is my P orbital. So let me draw the P orbital in the green color. This is my P orbital actually. One P orbital. Similarly, we have one more P orbital. You can see this is a three-dimensional shape. And then I have one more P orbital. This is the third P orbital, right? So instead of shielding it with spherical shape, if you have this gold here, let's suppose, and let's suppose you are shielding in this fashion, you have protection somewhere here, here, and somewhere in this fashion. Do you think this is more strong or this? Obviously this, because this is total protection. Here actually anybody can come from these directions, correct? Same thing here. Here you can actually penetrate from this direction. So the shielding effect will be little less in case of p orbital as compared to s orbital, because s orbital is spherical in shape. So if you have something here, it is actually totally shielded properly from all three-dimensional directions, because it is sphere. It is as good as putting a gold or precious precious article in a sphere, and that is shielded. And the p orbital has different structure, so the shielding effect is less. Similarly, d has all the more less shielding effect, right? So you must understand now that s orbital has maximum shielding effect, p has less, d has all the more less shielding effect. Now we'll see the importance of shielding effect actually. Okay, and before that, let's understand the orbital energy. Also, we have discussed this. The 3d and 4s orbital, actually the energy is almost same. In fact, 4s has lower energy than 3d, but the moment 4s gets one electron, we have seen that the energy rises up, and then the next electron goes in 3d. So we have seen that. Thus understand that 3d and 4s has almost same energy. Now let's talk about the atomic size. So if you see the atomic size trend, the atomic size number, actually the atomic radius decrease and then increase. If you see from here to here, it decrease, and then again it decrease, again decrease, same, again decrease, again decrease, again decrease. But after this, if you see, there is the increase. If you see here also, 195 to 175 decrease, 175 to 164 decrease, 154 decrease, 147 decrease, 146 decrease, 142 decrease, 139 decrease, and then again increased. Same thing here. Decrease, 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 decrease. It also decrease. It's almost same actually, I can say. So it decrease and then increase. Correct. The question is why? Why is this trend? See, one thing we should note here is, if you talk about the electronic configuration, for example, you take scandium. Scandium electronic configuration is 3d1 4s2. So let's assume this is my s orbital. It already has 2 electrons, right? This is s, and let's suppose this is my p orbital, sorry, d orbital. Here if you note that d orbital, 3d orbital comes, and then you have 4s orbital, correct? And the best part in this case is the next electron, and this is my scandium configuration. Configuration is scandium is AR this, and that's why I put argon here. This is my scandium. The next electron that is added to this to make it titanium is, the next electron will be added in p block, sorry, d orbital, not in s orbital. Again, to make it vanadium, the next electron will again be added to d orbital. Again, to make it chromium, the next electron will again be added to d orbital. So if you see here, what is happening is, see, the atomic size will be determined by s orbital, correct, because that is the outermost orbital. Now we are pumping electrons here inside, and you assume this is the figure. This is my s orbital, this is a 3-dimensional figure, and this one actually you see is my d orbital. The one in the blue is d orbital, and the one in the red is my p orbital. So in this case, the electrons are more and more electrons are added in the d orbital, right? You are adding more and more electrons here. As you go from left to right, you add more and more electrons in the d orbitals. So if you are adding more and more electrons to the d orbital, what will happen? The shielding effect will increase, okay, after some point of time. See, we know that this is d orbital, the red one has poor shielding effect. So initially if you add 1 or 2 electrons, the shielding effect won't increase that much, right? But as you keep on adding these electrons to this, the shielding effect will increase, and thus after some time what will happen is the shielding effect increases, and then this electron does not experience much charge from this nucleus, and thus it goes away and the atomic size increase. Okay, so if you see, the 4s has higher energy than 3d, and this is 4s electron actually which is deciding the size. You're adding more electrons to 3d. So as you add more electrons, you are adding more protons also. As you're moving left to right, you're adding more electrons, you're adding more protons also. So effective nuclear charge is increasing. Why? Because the shielding effect is poor for d orbital, thus the size decrease. Hope you understand. Why the size is decreasing from left to right is, as you're adding more electrons, you're adding more protons also. Effective nuclear charge is also increasing. Since the effective nuclear charge is also increasing, the size is shrinking. But after a certain point, since you already added a lot of electrons to this d orbital, the d shielding becomes effective. So once this d shielding becomes effective, right, the effective nuclear charge on this electron decreases. Just understand this. You're moving left to right, you're adding more protons, but the shielding effect is poor only. So effective nuclear charge on this electron is increasing. So this electron is attracted more toward this nucleus, and since this electron, the s electrons, 4s electrons are the one which decide the size of the atom, the size decrease. But after a certain point, this d orbital is almost filled. There is a repulsion here. There is a repulsion here in this d orbital, and the shielding becomes effective because this d orbital is almost filled, right? And in that case, the effective nuclear charge on this electron decreases. Why? Because of the good shielding effect now, because the d orbital is almost filled, and thus this electron goes away. This electron goes away, and thus the size increases because the size of these atom is decided by 4s2 electrons. I am talking about this series. Okay. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.